All right, hi class. We're going to practice a one more probability tree model just for us getting used to it, I think. And this one I'm going to continue to make a little bit basic. The next one's going to get a little bit more difficult, but it's really important that we master this skill. So let's say we have some snack choices available to us, and let's say let's skip this on down. Let's say we're talking about really healthy choices, chips and soda. Dentist. All right, so we've got chips and soda, and let's say we have three types of chips. Okay, I'm gonna make this one pretty easy. Let's say you guys have Takis. I know you guys like them. I'm not the biggest fan. Doritos. And here's my favorite. I just like barbecue chips. Delicious. And let's say you get chips and soda, so our second event is going to be a soda. The soda, how about Dr. Pepper? Oops, Dr. Pepper. Brain fart. Dr. Pepper, Pepsi, and let's just call it Coke. Okay. And I'm purposely choosing these so that they have different first letters in case you feel like you need to abbreviate them, because it's so hard to write three letters like barbecue. Ooh, lazy. This to be organized. So our first event, the first thing we're even just looking at right now, is going to be the chips and the soda. Easy peasy. So how do we start? Well, and I was telling you right now, all of these have an equal choice. So imagine you were to close your eyes and reach inside of a bag, and you had 3 bags, Takis, Doritos, or barbecue chips. Okay. Same with the soda. You close your eyes, you reach in, and you grab a Dr. Pepper, a Pepsi, or a Coke. All of which I'd be very much okay with. All right. So to start it out, to start our tree diagram, let's make our start. Okay. So far so good. Circle it. Okay. And now we need to recognize, hey, of our first event, how many different different options do we have available? How many choices? And it looks like we've got Takis, Doritos, and barbecue chips. Therefore, we have 3 different choices for our chips. So now, we are going to, from the start, we are going to branch out 3 different times, 3 different ways. Okay, and so we're going to go 1, 2, 3. I like to space them out because you never know when you need the space. And so we start here, and at the end of each of the lines, we are going to write with words, Takis, Doritos, and barbecue. Love barbecue chips. Okay, so are we done? No, not with the first event, because we need to represent what are the chances of us closing our eyes and getting any one of these chips. And since they are equal, and there are 3 of them, then you closing your eyes and grabbing 1 bag of chips out of the 3 would give you the fraction of 1/3, and we write that directly right on top of the line. Sometimes people write it next to, that's fine, so you can read it. However it works for you, be clear, make sure you can read your own handwriting. Beautiful. All right, so that's choice 1, that's our event 1. And we're done with that next part. Now, our second event, of course, is the sodas, and the same deal. There are equal opportunities of choosing Dr. Pepper, Pepsi, or Coke. So, here's what we're going to do. So from each of these, we are going to now continue to branch out. Okay, so from Takis, we need 3 lines to represent our 3 soda choices that would go along with the Takis. So we've got 1, 2, 3. From Doritos, 1, 2, 3. And from barbecue, making me hungry. Okay, so from there, and at the end of each of them, we're going to go ahead and write down Dr. Pepper, Pepsi, Coke. And we're going to do that on each of these branches. Ooh, technology. It's finished. All right, so we have Dr. Pepper, Pepsi, and Coke as three equal options, equally probable choices at the end of each of them. So, but we're not finished as well, because the same thing. If we have an equal chance of getting either of these three sodas, then we need to represent the chance of, for instance, getting Dr. Pepper. It is one option out of three. Therefore, we are going to write along each of those line branches 1/3, 1/3, 1/3. Okay. As a reminder, though, it's not always going to be the same. So don't get in the habit of thinking it will always be the same. So this is excellent. We have finished at least this part of our tree. Our tree is done, which is amazing. But we are not done until we list out the outcomes. So here comes the outcomes. Okay. So we're going to, remember, starting at the start, we're going to follow the line, and we're going to see which possibilities we could do. So we're going to have Takis and Dr. Pepper. I'm going to write Dr. P. We also have Takis and Pepsi. And then we have Takis and Coke. Okay. Now at this middle branch, we're going to follow, and we're going to have Doritos and Dr. P. Doritos and Pepsi. Doritos and Coke. And then last but not least, if we follow this branch on down from start to the barbecue, okay, we could have barbecue and Dr. Pepper. So, barbecue, BBQ, and Dr. P. BBQ and Pepsi. And BBQ and Coke. Excellent. So we have listed out using words the outcome, but we are not finished, because every single outcome we also need to state what are the probabilities of getting exactly this combination. So what is the probability of closing your eyes completely and randomly, blindly choosing Takis and Dr. Pepper, for instance? Well, to figure that out, we figure out what are the chances of you choosing Takis in the first place. So that is going to be 1/3. Okay. And we're going to combine that with the chance of you choosing Dr. Pepper out of all of the beverage choices. And that would be also times 1/3. Okay. All right. And so remember, multiplying fractions, you multiply straight across the numerators and straight across the denominators. So that would tell us that the chance of you closing your eyes and you actually getting Takis and Dr. Pepper is going to be a 1 in 9 chance of getting exactly that combination. And since, hey, Takis is still like 1 in 3, and Pepsi is always 1 in 3, if you're noticing something, since there are equal chances of you getting all the chips and equal chances of you guys getting all of the sodas, there's not an advantage to either one of them. Every single one of these combinations is going to have the exact same probability of being chosen. It's going to be 1/9. But still, you must show your work by filling it in. Excellent. Right on that. All right, so if we did this correct, here's one thing we should always be doing. Looking at this chance, it's getting Takis and Dr. Pepper and all the way down to barbecues and Coke, every single one of these has the exact same chance of being chosen just randomly. And that's all one chance out of 9 possible chances. Okay, not 9 possible combination choices. But one thing I want you guys to keep in mind is if we look at this right here, this column right here, and this is very important just for us to stay straight. If we were to add up all of these 1/9, 1/9, 1/9, 1/9, 1/9, 1/9, 1/9, 1/9, and we were to add them all up, if we did this correctly, it should actually equal 9/9, which is the same as 1, which is the same as 100%, which is what we want. That's a really quick way to check to see if everyone is accounted for, that you're not missing something, that your math is correct and all is well with the world. So why do we do this in the first place? Okay, well, that's to determine when I'm asking you questions, and I will ask you a question such as, hey, you guys, what are my chances of getting barbecue chips? I just really, really want barbecue chips. Well, we're going to find all the ones that have barbecue chips, 1, 2, 3. We're going to add up their probabilities, 1/9 plus 1/9 plus 1/9. Okay, and that gives us 3/9, or 1/3 of a chance of getting my awesome barbecue chips. Now, you could also have figured that out if you go all the way back over here to our tree, and I know that, hey, I know 1/3 of my total choices are going to be barbecue chips, rather. Okay, but what if I was to ask you something about, hey, what if I also like Dr. Pepper a lot, so what if I will be happy if I get barbecue chips or Dr. Pepper or both? Okay, so that one's a tricky question. Okay, so how many of these combinations have at least one or more? How many of them have one or more options where there's Dr. Pepper and barbecue? My favorites. So we go along the list. That's why we use words, and we say, oh, here's a Dr. Pepper. Oh, here's a Dr. Pepper. And we look, oh, barbecue, barbecue, barbecue. Now, that's 5 out of 9. And a lot of students, they'll want to say, oh, but this one is Dr. Pepper too. Well, this combination is already accounted for by the barbecue chips, so we don't count it twice. It's only one combination. If the combination already meets the criteria through the barbecue chips, then it doesn't need to meet the criteria through the Dr. Pepper. Okay? So in that case, if Miss Stevens is happy and she's getting her barbecue chips and her Dr. Pepper, then there's a 5 out of 9 chance that I will be quite happy with any of the options given here. Okay, so that's how we do another example of a simple kind of a probability tree where all the options have exactly the same chance of being chosen.